Hello, everybody. This is John Ross, and I'm here to explore some of our fifth grade standards a little bit more with you today. We are going to be specifically focusing on multiplying decimals by powers of 10. Our standard that we're focusing on is 5.NSBT.2, specifically indicator B. And so that reads as use whole number exponents to explain patterns in the placement of the decimal point when a decimal is multiplied or divided by a power of 10. So for our purposes today, we're really just focusing in on that multiplication side of this particular indicator. Our learning objective reflects that reality as it reads as I can use whole number exponents to explain patterns in the placement of the decimal point when a decimal is multiplied by a power of 10. All right, so for our I do portion of our little mini lesson, we have three problems, and these are similar. Note that they all consist of the same factor on the far left-hand side, 2 and 5/10, and that 2 and 5/10 on the right-hand side is multiplied by a power of 10. For number 1, that's 10 to the second power. Number 2, 10 to the third. And number 3, 10 to the fourth. And so I know that I can write this numerical expression out in its long form by noting 2 and 5/10 times 10 times 10. And so when I multiply 2 and 5/10 times 10, I end up getting the whole number 25. And so what essentially has happened is I have moved my decimal over. When I multiplied that 2 and 5/10 by 10, I moved that decimal over one place. And I dropped it to the right of that 5. But I'm not done, because I now need to take that 25 and multiply it by 10 again, because it was 10 to the second power, to find the true value of this numerical expression. So 25 times 10 is going to get me a final product of 250. And again, when I multiply that 25, and I have a decimal here, even if it's in hiding, as I sometimes like to call it, but that decimal has essentially moved over one space to the right. And so it is found here. And so what I can tell right now, an observation I make, is that basically I moved my decimal 2.5 over two spaces. If I have 2 and 5/10, and I want to multiply that 2 and 5/10 by 10 to the second power, that is essentially saying that I need to move my decimal over 1 and 2 places to the right. Cross out that old decimal and stick a 0 here for a placeholder. For number 2, we're going to see similar truths related to moving decimals when we are multiplying by a power of 10. So again, I know that 2.5 or 2 and 5/10 times 10 to the third power can be written in an alternative manner. And that alternative way of writing that numerical expression is 2 and 5/10 times 10 times 10 times 10. And so when I multiply 2 and 5/10 together, I'm going to get the result of 25. And so again, What that tells me is that basically I have moved my decimal over one place to the right. Now I need to multiply my 25 by this other 10. And when I multiply 25 by 10, that's 10 groups of 25. I end up getting 250. And so again, I have essentially moved that decimal over one more place to the right. But I'm not done because I still need to multiply that 250 by this final 10. And when I do that, I end up with the product of 2,500. Because again, I have moved that decimal over one more space. And so 2 and 5 tenths is the same, 2 and 5 tenths times 10 to the third power is the same as 2,500. And I can recall that that 3 right there, that exponent, tells me how many times I should move my decimal to the right. And so that's 2.5 times 10 to the third power. Move that decimal 1, 2, and then 3. And I'll drop it right there. I'll cross out this old decimal, try to put an X, and then I have 2 blank spaces right here. I need to place 2 zeros to represent or serve as placeholders here. And so this long form is not necessary if we are aware of the patterns that occur when we multiply a decimal by a power of 10. So in this case, I can just simply, for number 3, let's just put 2.5 or 2 and 5 tenths, and then I'm going to move my decimal over 4 times. And that's 1, 2, 3, and 4. I'm going to drop that decimal off. I'm going to cross out that old decimal. And now I have some blank spaces that I need to plug in with zeros to serve as place value holders, if you will. And so I've got, this is my ones place, my tens, my hundreds. So between my next place is my thousands. So between that, I need to put a comma. So I'll go ahead and put that there. And then I have 5 in my thousands and 2 in my 10,000s. So 2 and 5 tenths times 10 to the 4th power has the same value, is the same as 25,000. And finally, we have some extra practice problems here. And so I'm going to go ahead and write 32 and 4 tenths under here. And I'm going to note that my exponent is a 4, so that's 32 and 4 tenths times 10 to the 4th power. And that tells me that my decimal should move 4 places to the right. So I'm going to do a little hop here. 1, 2, 3, and 4. And I'm going to drop my decimal. And then I'm going to plug in some zeros to serve as placeholders. So put a 0 there, a 0 there, and a 0 there. And recall that that decimal needs to disappear. Let's see if I can use my little eraser. There we go, good. And I need to note that this is the ones, the tens, the hundreds, so I need a comma here. And then I've got my thousands, 10,000s, and my 100,000s. So 32 and 4 tenths is equal to 324,000. And that's it. Nothing in the hundreds, tens, or ones place or beyond the decimal, which again, I often like to say it's hiding, but it is there nonetheless. All right, so we next have 4 and 8 tenths times 10 to the second power. So just like we did before, I can put my 4 and 8 tenths here. And then I can note that I have to multiply 4 and 8 tenths times 10 to the second power. So that's going to be 4 and 8 tenths times 10, essentially. But if I am comfortable and familiar with my patterns as it relates to how many times we should move that decimal is determined by the exponent that is found within the power of 10. We don't have to write that out in long form. So we can just simply move that decimal 2 places to the right. 1, 2. I can drop it off. But again, I must remember, and I have students periodically who sometimes forget that, hey, I need to plug in a 0 here for a place value holder. Because if I don't, I end up with just 48. And 48 is much different than 480. So 4 and 8 tenths times 10 to the second power equals 480. And I don't have to write my decimal, but my decimal is there even if it's in hiding. Now here I have 524 thousandths times 10 to the third power. So what I can do is I can again move that decimal over 1 space, 2 spaces, and then 3, and drop it off. And so I know that 524 thousandths times 10 to the third power is equal. It is the same as 500,024. And again, that 3 is a big clue as far as how many times we need to move that decimal over to the right, and that 3 is our exponent. Finally, just a couple more. We have 1 and 6 hundredths. And so that 1 and 6 hundredths is being multiplied by 10 to the third power. And so that tells me that I can move that decimal over 3 spaces. 1, 2, and 3. And I drop it off. But note, there is a space here. So I must plug in a 0 to serve as a place value holder. And I also need not to forget that I need to erase that decimal. It is no longer there. I have moved it. And so 1 and 6 hundredths times 10 to the third power is the same. It equals 1,060. And finally, we have 35 and 4 hundredths times 10 to the fifth power. And so, again, I can zoom in on my exponent, which is a 5 here, and that tells me that I need to move my decimal over 1, 2, 3, 4, and 5 places. I drop off that decimal. I want to erase my old decimal. Come on. There we go. And then I need to recall that I must fill in those blank spaces with a 0 to serve as a place value holder. Because if I don't, I end up with 3,504, but that is not accurate. I must plug in those zeros, because with those zeros, I actually end up with, well, first let me write these digits in order, and then we can place our commas where they should go to help us better read the number. that we just created when we multiplied 35 and 4/100 times 10 to the 5th power. And so, move that over just a wee little bit. And I want to start out by noting that this is my ones place. This is my tens, this is my hundreds, then I have my thousands. So in between my thousands and my hundreds, I need to put a comma. And then I have, again, my thousands, my 10,000s, my 100,000s, then I have my millions. So in between my millions and my 100,000s, I need another comma. So 35 and 4/100 times 10 to the 5th power equals 3,504,000. And so, friends, I've walked you through a little bit of 5.NSBT.2, and we have explored and used whole number exponents to understand the patterns and the placement of the decimal point when a decimal is multiplied by a power of 10. So at this time, I'm going to ask that you move into your independent practice.